So every individual atom on the periodic table has its own tile, which includes a bunch of different information that we can learn about each individual atom. Every tile contains 4 different pieces of information: the atomic number, the chemical symbol, the element name, and the atomic mass. And we're going to talk about each one of those individually. The first is the atomic name. As it's called, it is the proper name of each individual unique element. Every element has its own unique name. In this case, carbon is carbon. The next is the chemical symbol, and your chemical symbol is always going to be 1 or 2 letter abbreviation for the element name. In this case, the chemical symbol for carbon is just the letter C, so it's a 1-letter abbreviation. If there is an element that has 2 letters, then only the first letter will actually be capitalized. The second letter will be lowercase. So for example, neon's chemical symbol is Ne, and notice that the N is capitalized, but the E is actually a lowercase. A lot of the elements that we're going to see, their names are, the letters, the symbols that they use are based upon their original Greek or Latin names. So for instance, iron, its symbol is Fe, which comes from the Latin word ferrous, which means containing iron. So you can't always assume that the letters are based upon what we now call the element, because some of them are based on other words. Next, we have the atomic number. It shows you how many protons are found in the nucleus of that particular element. So every element has its own unique number of protons. So in this example, carbon has the atomic number of 6, which means that there are 6 protons found in the nucleus of every single carbon atom. It's the number of protons that determines the element type. So there will be no 2 elements that have the same number of protons. Every single element will have its own unique number of protons. If the proton number changes, then the element will also change. Okay. Let's see what else. Since atoms are electrically neutral, meaning that however many positive charges are, there is an equal number of negative charges. That means that if we know that the atom has 6 protons, we can also determine that it's going to have 6 electrons, because the number of electrons is going to be equal to the number of protons in that atom. Next, we have atomic mass. Atomic mass is the average mass of all of the different atoms of a particular type. These are called isotopes. We're going to talk about isotopes a little bit later in this unit and get more specific about it. But right now, just know that the reason that there is a decimal is because it is an average. It's a combination of many different masses all added together and averaged out. Now, since only protons and neutrons add to the mass of the atom, we can use the atomic mass and the atomic number to not only know how heavy an atom of that type is, but we can also use it to figure out how many neutrons are in that atom. So, for instance, the atomic mass, which is rounded to the nearest whole number, the atomic mass rounded to the nearest whole number minus the atomic number will give you the number of neutrons. So in this case, we're going to take 12.011. We're going to round that to the nearest whole number, which would be 12. Now that 12 is your neutrons and your protons. Since the atomic number is the number of protons, we can subtract the 6 protons, and that leaves us with 6 neutrons. What this means is that on average, every carbon atom will have 6 neutrons in their nucleus. All right, let's do one more example. If you're watching this video, you can go ahead and pause and try this out yourself before we go over the answers. Okay, so first off, the element name, we can get that right from the tile, which is manganese. The chemical symbol, again, right from the tile, which is Mn with a lowercase n. Atomic number is up in the left-hand corner, which is 25. And atomic mass is 54.938. Now from here, we can also determine our protons, electrons, and neutrons. Protons is the same as the atomic number, so that's going to be 25. Since this is an atom and it is electrically neutral, if there are 25 protons, there's also going to be 25 electrons. And finally, to find the number of neutrons, we're going to take our rounded atomic mass, subtract our atomic number, and that will give us the number of protons. So we have 55, because 54.938 would round to 55, minus my atomic number of 25, giving me a total of 30 neutrons.